We've all heard the dream of AI, right? An agent that can actually do things for you. Book your travel, analyze a spreadsheet, you name it. And yeah, proprietary models like GPT-4 are getting pretty good at this. But this has created this huge challenge, leaving the open source world way, way behind. But what if there was a simple, practical recipe to close that gap? Well, today we're diving into a paper that claims to do just that. First, let's just get a handle on how big this problem really is. Take a look at this. On a pretty basic house searching task, GPT-4 gets it right 77% of the time. Pretty good. Now look at the open source models. They're at or near zero. I mean, they are failing almost completely. This isn't just a little performance gap, it's a chasm. It's been a massive roadblock for the entire open source community. But okay, what if I told you there's a way to take these exact same models and crank their success rate up by as much as 90%? That's the breakthrough we're going to unpack. And this isn't some pie-in-the-sky new model. It's a totally practical set of steps that makes the AIs we already have so much smarter. So how do you even start to fix this? Well, first we've got to figure out why these models, which are powerful enough to write poetry and code, are just falling flat on their face with what seems like a simple task. So the researchers had to put on their detective hats and diagnose the exact points of failure. And it turns out the mistakes they make are surprisingly predictable. They basically fall into three main buckets. First, they pick the wrong API. This is like trying to hammer in a screw. The model gets the goal, but it just grabs the completely wrong tool for the job. Second, it provides the wrong arguments. Okay, so here it picked the right tool, the screwdriver, but it's trying to use it on the wrong screw, or maybe it's just turning it the wrong way. And third, and this one's my favorite, non-executable output. This is when the model just gives up and starts talking to you, spitting out conversational text when it's supposed to be generating clean, runnable code. So how do they tackle these problems? The solution isn't some brand new multi-million-dollar model. Instead, they got clever. They combined three well-known techniques for machine learning into a simple but really powerful three-part recipe. And these are the three ingredients for success: model alignment, demonstration retrieval, and some really strict system prompts. Each one of these is designed to surgically fix one of the failure types we just talked about. So let's break them down. All right, first up, model alignment. Think of this as a bootcamp for the AI. You take the model and you drill it on thousands and thousands of generated examples of how to use tools correctly. It's kind of like giving a new hire a simulator to practice on, over and over until doing the right thing just becomes second nature. This directly tackles that wrong API problem by helping it learn the right patterns. The second ingredient is demonstration retrieval. Now, this is really cool. You can basically think of this as an open book test for the AI. When the model is trying to solve a real problem, this system jumps in like a super fast research assistant. It finds a few perfect human-made examples that are relevant to the exact task at hand and gives them to the model as a little cheat sheet. This gives the AI a perfect template to copy, which massively reduces those wrong argument errors. And finally, we've got system prompts. This step is all about forcing the AI to focus. You give the model a very specific job title and a strict set of rules right up front. I mean, this quote says it all. I will generate code only. It's like putting blinders on a racehorse. It just eliminates all the other distractions and tells the model, stop chatting and just give me clean, executable code. And just like that, the non-executable errors, gone. So that's the recipe. We've aligned the model, given it a cheat sheet, and put blinders on it. The big question is, does this actually work in the real world? Well, the results are pretty mind-blowing. Let's go back to that house searching task where the open source model was crashing and burning with only 7% success. After applying this three-part recipe, the exact same model is now succeeding 83% of the time. That is an absolutely colossal leap. We're talking about going from basically useless to an expert performer. This one chart just says it all. And this wasn't just a one-hit wonder. Across a whole benchmark of different jobs, the enhanced open source models became competitive with, and in some cases, even better than GPT-4. We're talking about real-world stuff like checking the weather or using an API for cat photos. The gap wasn't just narrowed. On a lot of these tasks, it was completely erased. So, what's the big takeaway here for all the people actually building things with AI? This is more than just a cool academic finding. This is a clear, practical blueprint for turning these powerful but sometimes unreliable open source models into agents you can actually depend on. But here's the part that really gets me. The amount of human effort needed to add a new tool to this system, Just one developer day, not weeks, not months, one day. That is an absolute game changer. It makes this whole approach incredibly practical for developers and small teams who don't have the insane resources of a giant tech lab.
Okay, so let's wrap this up. What are the key things to remember? First, and this is the big one, open source models can compete with the best of the best when it comes to using tools. Second, the way to get there isn't some secret sauce. It's a low-cost, practical recipe that people can use right now. And third, let's be real, there are still challenges ahead, especially in what the paper calls advanced reasoning. You know, complex stuff like manipulating a spreadsheet based on a vague command.
And that really leads us to the final huge question. This recipe is amazing for teaching an AI to follow instructions with tools it knows. But what happens when a task needs real creativity? When it needs to invent a new way to combine tools or think through a complex, multi-step problem? What is the next frontier that will take AI agents from just following instructions to genuine problem solving?
This is for entertainment purposes only.